Hello, this is section 9.2 testing the difference between the two means of the independent samples using the t-test. So the t-test is used to test the difference between the means when the two samples are independent and when the samples are taken from the two normally and the approximately normal distributed populations. The samples are the independent samples when they are not related, and we assume the variances and therefore the standard deviation are not equal. The formula for the t-test uses the standard deviation of the samples to find the standard error of the difference between the two means since the population standard deviations are not known. So assumption for the t-test for the two independent mean when the sigma sub 1 and sigma sub 2 is unknown. So when the sigma sub 1 and sigma sub 2 is unknown, we use a t-test. Unknown case, we use a t-test. Okay, so samples are the random sample. Sample tests are independent for another. And when the sample size are less than 30, and then we need to believe that population must be normally distributed or approximately normally distributed. So formula for the t-test for the testing the difference between two means independent sample, and then this is the formulas that we're going to use, okay? Variance is assumed to unequal and degree of the freedom that we have to use, which is n sub 1 minus n sub 2, but we take the smaller one. Assume that the assumptions are met. Okay. All right, so let's do the example. So weight of the vacuum cleaners. Some right vacuum cleaners have either a hard body type or the soft body type. Shown are the weights in pounds of the random sample of each type. At the alpha equal to 0.05, can it be concluded that the means of the weights are different? Okay, so hard body type and then soft body type. So state 1, we need to state the null and alternative hypothesis and identify the claim. So h of 0 is mu sub 1 equal to mu sub 2. And then h of 1 is mu sub 1 is not equal to mu sub 2. So the alternative hypothesis is claimed this time. And then we are using the table, which is the table T table, which is the table F. So degree of freedom, which is, we need to take the smaller size. So there's a 6 minus 1, so we take the 5. And then alpha equal to 0.05. So critical value that you're going to find from the table is going to be the 2.571. So which means this is a two-tail. So on the normal curve, the area has the n. So one is a negative 2.571. The other is 2.571. So, and then the shading area is the critical region. Step 3, compute the test statistic. So we also need to find the x1 bar from the hard body types, which becomes 17.5. And then the x sub 2 bar is going to be 14.7. And also standard deviation S sub 1 is 3.699. The x sub 2 is 4.761. So t value is going to be the x sub 1 bar minus x sub 2 bar. Subtract the mu sub 1 minus mu sub 2 over plus S sub 2 square over n2. Plug it in. So 17.5 subtract 14.7 over 3.699 square over n1, which is 17, and 4.761 square over 6, which come out as 1.495. So 1.495 is about here, right? 1.495, which is not in the critical region. And then if you use the p-values, use the t-value, which come out as almost 0.1700, compared to alpha, which is 0.05, which is not true. So we have to, as a conclusion, as a decision, we do not reject the null hypothesis. And then summarize means you have to say there is not enough evidence to support the claim that the mean weight of hard body or a soft body upright vacuum are different, which is not that much of a difference, right? Okay, alrighty. Let's look at the next page. Alright, next page, we're gonna use the confidence interval to prove this. Okay, so confidence interval for the difference of the two mean is sigma sub and sigma sub 2 is the not given. And then for the independent sample, so we have to use these formulas. Okay, so we are using these formulas to find it. Okay, so let's look at the next example to the testing by the confidence interval. So age of the homes. Whitening, India leads the top 10 cities with the oldest houses, a list with the average age of the houses being 66.4 years. Further down the list, residents of Franklin, Pennsylvania, with the average house of the age of 59.4 years. Researchers selected a random sample of the 20 houses in each city and obtained the following sample data. So one is a whitening, so mean and the sample standard deviation. And then at the alpha equal to 0.05, can it be the conclude that the house is a whitening older? Use a p-value method. This time also to construct the 95% confidence interval for the difference between the two means using the sample data mean. Okay, so state the null hypothesis and alternative hypothesis. Okay, so h of 0 gonna be the mu sub 1 same as mu sub 2, and h of 1 is mu sub 1 is greater than mu sub 2, which is that's a claim. So the test T is equal to x of 1 bar minus x of 2 bar. Subtract mu sub 1 minus mu sub 2 over the s of 1 square n1 plus s of 2 square over n2, which is plugged in. 62.1 subtract 55.6 minus 0 over 5.4 square over how many houses? 20 houses, right? Okay, and then 3.9 square over 20, which come out as a 4.364. So which means it's a right tail. So which means t-value is a 4.364, and then we're looking for the p-value, which is the area. How much is the area? So the p-value using the t-value 4.364 almost give you the 0.00005639, which is almost come out as 0.001. So almost 0.0001. Compare alpha, which is 0.05, right? Which is true, right? So we just say reject the null hypothesis. And then what do you summarize? There is sufficient evidence to support the claim that the mean age of houses in Whitening, India is greater than the mean age of houses in Franklin and Pennsylvania. All right, so that's how you conclude it. All right, okay, so yeah, thank you for listening.